All right, good morning, learners. We are going to hand out the test as our first thing. Yeah. All right, close the door, please. All right, Riley, come here.
Riley's not here.
Natalie, come here. You did horrible. Caden, come here.
Absent too.
Carson, come here. You did horrible.
Yay!
Kaylin, you did horrible. Annie,
You liar.
you did horrible.
You did even worse.
Helios, you did horrible.
Are you just gonna say horrible?
Ava,
You should say
Where's
I
Ava?
did great tomorrow.
you did horrible.
Absolutely awful.
Kylie,
Imagine if I got it.
you did horrible. Oh,
Imagine
sorry.
if I didn't.
Okay, all joking aside, I've not graded your test or who's the other person that you graded? The first grade? No, I graded.
Oh, so all those horrible.
All right, all those horribles were hundreds. They did a very good job.
Okay.
All right, the rest of you did not get a perfect score, but most of you did fine. Maddie.
Which one?
I
I
only
write
have
Madison
one.
on my paper. I write Madison on my paper. So if she says Maddie, it's Maddie. And I write
Nathan.
Madison.
Mason, probably. Richard. Jake.
Keep up the good work.
Devin.
Over here.
Not yet. I'm not going to be happy with that. Laura.
Oh.
Grace.
Did I really
Yes.
do that to myself?
I've never had any.
All right, who doesn't have a test?
78 out of 80. It's not that bad.
Caden. Come here. Oh, wrong one. Sorry.
Ah, so weird girls from that.
Okay. Mouths are closed, so I can talk, please. Mouths are closed. So I still owe you your test, and that's it. Everyone else has a test, correct? And David, I haven't graded yours yet. All right, mouths are closed, and you're listening. So as a class, we kicked butt, took names on that test. I mean, I had more perfect papers than, wow, it was really good. Guess which ones gave us problems? The subtraction ones and the inequalities, because a lot of you saw that less than and you immediately assumed, oh, that must be a less than symbol. It's only a less than symbol if it says the word is less than. 9 less than 10 doesn't mean less than symbol. 9 less than 10 means 10 minus 9, right? When it says 10 is less than 20, notice the word is there, then it's a less than symbol. All right, pretty much on the first page, with exception of the subtraction ones, number 6 and number 3 and number 4, you guys did fine. Any questions on page 1? All right, page 2. Shame on you if you got 7 and 8 wrong, right? I believe out of my 2 7th grade classes, I only had 1 student that got 7 and 8 wrong. And I'm not sure what in the world is going on there, but remember the opening always points to the larger number. Once again, if there was a mistake, it was on subtraction. Occasionally, number 11 was a little bit iffy. Most people, I mean, not 99% of the people got number 11 right. But a couple people still didn't understand this word between. Between means that there's a number smaller and a number bigger than you if you're in between. Solving equations, the bottom of the page, we did fine. A couple people just had some bad math, but for the most case, we did good on that. Flip it over. The inequality ones, occasionally somebody graphed it incorrectly. I also took off points if you didn't put arrows on your number line like I said I would. I didn't take off like a point for each one, but I did take off 1 total point. I still had 1 student, I don't know if it was this class or the other class, when they graphed, they didn't put the circle on the number line, and they didn't put the number underneath, and they didn't put the shading on the number line. There was one student, I don't know if it was this class. So I didn't take off points because it was correct what their numbers were, which way they shaded, but I did circle it and I did show you how it should look. All right, the one word problem, most of the class got it right. There were a couple different ways to do it. This person here who is, I got Riley's in my hand right here. She set it up perfect. She set it up as an equation, solved the equation. She did it right. She even told me Mary has 21 nickels and 10 dimes, even though the question says how many dimes she has. I didn't take off to that. If you did not write your word problem as a statement at the very end, I took off for that as well too. Yes? You're the one I'm talking about. I didn't take off any points. I just say the circle has to be on the number line and the shading has to be on the number line. Right? But I didn't take off, I took off points for the one you missed. 9 times 3 is 27. All right. I knew I had one student do that. Any questions on the entire test? As always, I don't put a grade on it. I simply put how many points out of how many points. It's up to you to pull out the calculator and to calculate yours as percentage. Questions? All right, homework. Since I just used up that time to talk about the test, then we'll move right on to homework. Any overall question? We're not going to grade it. I will grade it. Any questions on the homework? All right, so let's just move on to collect it. And we'll move on. All right, everyone else, I'm going to show you the homework and you're going to copy it down. No test or quiz this week. Next quiz or test is, I believe, on Monday, and we're going to have a quiz. All right, yep, that's right. Nothing going on this week except for classes, quiz on Monday. Here's your homework, copy down. Question from Jake, what is it? Question from Jake, what is it?
I realized we did something wrong with the homework.
Can you fix it and have it done by student advisement?
Yes.
If it's in the box or on my desk, then it's not a 0. All right, today's class is a little painful, and I will be mean to you for the first 10 minutes or so. So being mean to you is a technique, not a an actual being mean to you. My claim, and I could be wrong, but period 1 proved me right. My claim is that none of you can explain why we call a number a number. I'll explain that further. My claim is that none of you could explain to someone who came into the room and like, well, I don't know how to read numbers, how to read a number. That's my claim. Period 1 proved me true. Like not a single person could tell me the rules. Like, how do you read a number? That's what today's class is on, how to read a number. Really? That's it. But I'm going to claim it. I don't think that you can tell me how to do it.
Probably not. Because it's a number. Because people that made English got the paper. You read it by reading like the numbers spelled out.
Okay. So technically this section, now to turn our brains on, we're listening. Technically this section is called the decimal system. So you would expect that we're about to do what? Decimals. We're not doing any decimals.
What?
We will start decimals tomorrow. Listen, please. We'll start decimals tomorrow. And the main purpose of this chapter is to go over how to add, subtract, multiply, and divide with decimals. Yet today's section is called the decimal system. We're not going to see a single decimal. Okay? Go figure. All right. So I say that today is an easy class, meaning like when it comes down for you to do your homework, you'll be fine. Right? But my claim is that none of you can explain to a person who couldn't do this work how to do it. None of you. Let's see if I'm right or wrong. All right, so we're going to do 3 things today. I'm going to do something called writing a word form of numbers. I'm going to give you a number. You're going to write out the words of that number. This is what I say none of you could explain how to do it. You can probably all do it, but none of you could explain to someone how to do it. And then we're going to do the reverse, the converse, right? We're going to, I will give you the words, you're going to write the number, right? And then lastly, this is probably new, we're going to write a number in what's called exponential form. So of the three things, the last one is new. The first two, I'm going to say you already know how to do it, just that no one could explain how to do it. All right, so it's pretty much all easy. So good day. All right, some background information. How many numbers do you see up there?
7.
There are what, 7 digits, right? Pick one, anyone.
4. 7.
All right.
8.
4.
What is, I heard 4 the most. What is that number?
4.
Anyone will make an argument it's not 4?
It's a digit. It's 6.
That's 40,000.
Oh, it's 40,000, right?
Oh.
So who's right? Is it 4 or is it 40,000?
40,000.
Okay, so that's kind of what we're talking about today. We're talking about place values and how to read numbers. Oh, by the way, can anybody read this number?
3,240,000.
Read it.
3,247,521.
My claim is probably everyone can do that, but no one could explain to, I don't know, a foreign person that walked in here how to read the numbers. Like, you couldn't tell me the rules,
Probably not.
right? So that's what we will talk about. Oops. That's what we will talk about. All right, so last class we talked about exponential numbers, right? For instance, 10 to the third, 10 to the fifth, right? 10 to the first. We usually don't write anything to the first, right? It's just extra work. So we usually write 10 to the first as 10. So that was last class. Well, it turns out that our number system has 10 numbers in them. That's why we call it a base. It's based upon 10 numbers. What are those 10 numbers, by the way?
1, 2, 3, 4,
Nope.
5, 6, 7, 8, 9, 10.
Nope. What? Oh,
Infinity.
0 is the first number. Our numbers start with 0 and end with 9. There are no other numbers, and I don't mean like value-wise. I'm talking about digits. There's just 0 through 9. There's no number 10. 10 is a mixture of 1 and 0. Okay. Not all civilizations had base 10. For instance, I forget if it was the Incas, the Mayas, or the Aztecs. They didn't use 10 numbers. They used more. There's a civilization that used 60 numbers.
What?
60 numbers. In your kindergarten of that civilization, you had to learn 60 numbers. Right? Electronic devices, guess how many numbers? Nope. Guess how many numbers? There's only 2 numbers. All electronic devices
0 and
that have a
1.
computer in them only have 2 numbers.
0 and 1.
It's called a base 2 system. In a base 2 system, 0 is represented by, well, what's 1?
1.
What's 2?
There's no 2.
There's no 2. So when we have no more numbers, what do we do in base 10? Like when we get to 9 and we need to go 10, what do we do? But what do we do to write the number? Well, how do we do that? No, you can't explain it, can you? What do we do? What do we do? We move over a place and we go back to not 0. We go to 1 and put 1, 0. So guess how they write 2? That's 2. What's 3?
1, 0.
There's 3. What's 4?
1, 2.
There's 4. What's 5?
But there's no 2.
Oops. Thank you. Sorry. What's what other about 4? What's 5?
1, 1, 0.
What's 6?
1, 1, 1.
What's 7? What's 8?
Makes no sense.
If you only have 2 digits, 0 and 1, what do you have to do? You got to go to the next column every time you run out of digits. What happens when we get 9? We have no more digits. So what do? We go over 1, we write a 1, and the first digit becomes a 0. That's the same thing in binary. You only have 2 numbers, 0 and 1. I just used them up. This is 0, 1, 2, 3. When they're out of digits, I have no more digits. So what do? They do the same thing we do. They go over, write 1, 0. But that's the number 2. Well, what's number 3? Well, it's the first digit's 1, the second digit's 1. That's 3. Go figure. Base 10, though. This is just a interesting thing to show you. Base 10, we got 10 numbers 0 through 9. 0 through 9. 0 through 9 are all the numbers. No, we're not going to count because we just did this. When you get to 9, you got to move over one decimal or one place value. We write 10. All right, place value. Yes, I'm going to make you think this through. Place value. Now, it was called decimals. We'll get to that tomorrow. We're going to talk about whole numbers today. So in place values, it should be a review. What's the first column called? It's called the ones, right? Write this down, box 1.
You can go to the paper.
As soon as you get your paper, write this down, box 1. As soon as you get the paper, write this down, box 1. All right, place value. Place value.
I was gonna say, we're just not taking this.
Yeah, no, that won't be ever happen in this class. When you get to geometry, there will be a time when I don't hand out a sheet of paper.
Don't just write everything.
Okay, place value is a numerical value of every individual digit of the number. Yes, this should be reviewed. This should not be new. You probably did this in first grade, and second grade, and third grade. Probably somewhere around fourth or fifth grade. You stopped. Now we're coming back to it. Numerical value of every individual digit of a given number. Lots of digits, lots of columns. Each one has a numerical value. And by that I mean the column, not the actual number. This is the
Ones.
This is the
10.
so forth and so on. If you need to write that down, please write that down. If you've got this memorized, you don't have to write this down. It is a review, but you're going to have to remember these. So if you don't, then you need to write them down. We okay? Or do we need to pause? Tony, are we good, or you want to pause? Okay. Place of values. Oh, and it never stops. It continues on marching on with this way. And it also goes in the other direction tomorrow.
That's great, isn't it?
Okay. All right. Should not be new. All right. It makes sense to write them vertically. Don't do this yet. It makes sense to write them vertically because we read left to right, top to bottom, right? How do we read numbers? We read numbers from right to left or left to right?
Right to left.
Well, for values, we absolutely read them from right to left. We go to the ones place first, then the tens. But we actually read like language. Read the number, we do go left to right, okay? But if we're talking about the values, no doubt, we go from right to left, okay? So if we're talking about the individual place values, then it makes more sense to write it in this format. But I don't know, in my head, I'm thinking vertically. When I'm looking at the numbers, though, I'm thinking horizontally, right to left. All right, I said we're going to play 3 games today. Here's the first one. I'm going to give you a number. You got to tell me the words of that number. This is what I'm going to say that none of you can explain to me how to do it. So I will give you, I don't know, 3 or 4 chances, and then we'll stop. Give me a 4-digit number.
5,233.
5,233. All right. I'm a foreigner. I don't use a base 10 number system. I walk in. All right. Madison, tell me how to read that. Tell me what the rules are. How do I read it?
Left, right.
Okay, so first rule is you must read left to right. First rule is good. That's good. Period 1 got that one as well, too. All right, tell me what to do next.
We did it.
See what I mean? Who thinks they can tell me the rules? I'm not looking for 5,233. I want the rules. Because the person walks in doesn't know what to do. Tell me the rules.
No.
This is hard. No point. Exactly. And my claim is that none of you can explain it. And I will say this. I'll give 2 more chances. Anybody want to tell me what are the rules? Go. We already got that. Left or right. Got it. Now what? I don't know. I just say the number. Last one. Go. What are the rules? Okay, so we'll give up there. Most of you have never thought this through. Math, we say, is a very precise pursuit of study. It's based upon logic. It's based on things that are true. And there are a few things that are based upon just somebody made up some rules. This is one of those ones where somebody just said, hey, we're going to make up the rule of how we name this thing. All right. First rule is left to right. Second rule is you read from comma to comma. You read the number till you get to the first comma and you stop, and then you start over again. So for instance, bigger number, 1, 3, 4. What's that number? 1 million, you stop. Then you go on to these 3 digits and you say,
345,000.
then you stop, and then you go on to these 3 numbers. So the second rule is you go from comma to comma. But then we got more rules. When there are 3 digits, what do you always say? When there are 3 digits, what do you always say? Okay, we already said that. If there's 3, hey, I got 3 digits between the commas, what do you always say?
100.
You say something 100, tens place, ones place. But that's not the rule when it's a 0. What do you say now?
45.
All right, then you say tens place, ones place. And if there's a 0 there, you say? Yeah, but if there's 3 zeros, get what you say? You say nothing. Somebody made up these rules, right? Do you say nothing? Yeah, you say nothing when there's zeros there. It's like somebody just randomly made up some rules. So I'm not going to claim that I actually have to teach this to you. I think everyone could tell me, oh, by the way, what's the number?
1,200,000.
See what I mean? You said nothing. Yet there's numbers there. We said that 0 is a number. You didn't say me that's 0. Why not? Somebody made up this rule. I don't know who did it. It wasn't a mathematician, right? It was probably somebody that has an English degree. And they said, this is how we're going to read numbers. Maybe it was a business person, okay? But the rules themselves that I will claim that all of you know, none of you could explain. What? They're not a placeholder. They represent a value. And what's that value? Nothing. 0. But 0 is a number. Remember we said base 10 number. What's the first number? Well, if 0 is a number, then it's not chump change. It counts for something. It counts for 0. Okay? So there are those basic rules. The basic rule is comma to comma. And then there's a rule for if there's 3 digits. There's a rule for there's 2 digits. There's a rule if there's 1 digit. There's a rule if there's zeros. Okay? So keep that in mind when you do this. So your job is now to read from comma to comma. All right, you see a comma? How many digits do we have?
2.
So we use the rule for 2 digits. Rules for 2 digits is you say tens place, ones place. So what's that number? 47. But why don't we say 47 10,000? Isn't this in the 10,000 plot? Spot?
That was 40.
Agreed, but why do we say 1,000 and not 10,000?
Because it's,
Do we ever say 10,000?
yeah,
When?
if it is 10,000.
No, we don't.
Yeah, if it's the number.
Oh, if it's the one case, you want to see how arbitrary this is? The one time that you say 10,000, if it's literally a 1 and a 0. But what if it's a 2 0? Do you say 20 10,000s? See what I mean? Who made up those rules? Not a math person. They're crazy. They're made up. Right? But you all know how to do this, yes?
Yes.
So I'll stop right here. That gets me a little bit animated because as a math person, like, hey, you got to stick to rules, right? You can't just make up rules as you go along, and that's what kind of like it seems like somebody did. So, oh, by the way, what's the answer here?
47,000.
Comma 521. Now there's debate about whether you should put the word and 521, or is it 521?
521.
Would it be wrong if I said 521?
Yes.
Arbitrary rules. Some books it'll say the word and, other ones. Now somebody wanted to argue with me in first period, like if you see the word and, that's actually the decimal place. And that is true. But it's contextually based. Meaning like we got to make sure we're really in decimal land or we're in whole number land. And that's why we can say we're in whole number land. So if you see an and here, it's okay, it's not a decimal place. I'm a non-and person. You'll see me like one time use the word and, but I'm a 521 person. Yeah. Yes, you do. You already copied it down. Okay. All right. So when we read this, we go from left to right. We read, it says 3 digits, but what it really means is comma to comma, right? So this is 47,000, comma, 521. Why did I move the comma? Okay, there we go. We good? Does anyone not know how to do this intuitively? So let's run through this real quick. All right. What do we got? David, you read it to me. What's that number? Don't overthink this. What's that number? Just tell me the number. 1. What place is it in? Ones, go with me. Tens. All I'm doing is reading these words. So this is 1 million, comma, go. Keep going. Let me catch up. That's a lot of words, right? I leave the space there because some people don't put a space there for real. Some people want to put the word and there. 521. And we're talking about how people would normally speak. I think more people when they're speaking say 521 than say 521. At least that's my belief. All right. Yeah, we got this. All right. You know me. You haven't taught me anything, Mr. C. Well, I taught you that you can't tell me the rules, right? That would be the one thing I taught you. All right. So we'll just do this one time, and then we'll call it quits. At least for this thing. I need you to write the words for all of these. Put the commas in the right spot. There's 4 of them. Obviously, this one is a pain in the butt, but the other 3 aren't too bad. If you have zeros, do you even mention them? For some reason, we skip over zeros. It seems like they don't get any. You got this already done? Do it. Probably so.
Building an extra league.
Someone is trying to escape the school. I don't know.
Or it's just my dad.
No, the construction is all going to be on that end.
Oh yeah, my dad's still on that.
Oh, he is.
He already did that.
Nice. Probably.
So can we still put like and?
You can if you like. If it makes more sense to you. Tomorrow when we talk about decimals, we're going to say that the and is the decimal place, but it's contextually based, meaning like just because there's an and doesn't mean it's always a decimal place. It has to make sense in the context of the number itself. Anybody need help? This is probably the pain in the butt one because it's like, this is a lot of writing for a big number. I will probably not ever put a large 6 or 7 digit number. There's it could be a 9-digit number, but if I do put something that large, I will include a bunch of zeros so that the amount of writing you have is limited. And also, if I put a bunch of zeros, I get to figure out whether you really know what you're doing or not. You good? Making progress? Anybody need help? She'll take roll while you're working. E-learners, I'll come back in a second. I think they're finishing the install of the sink over there. They're putting a sink in the. Riley and Caden, right?
Yeah.
All right, let's go over this. First one, upper left, who's got it? Go for it. 7,431. 30 what? 33. 33. Yes? Okay, that's better. All right, who wants the next one? Lower left. Go for it. Macy. Wow, that was an easy one, right? So even if I give you a lot of digits, you can actually get that one done pretty quickly. All right, let me catch up. There we go. Oops, sorry. All right, who wants the upper right? Somebody new. Thank you, Madison. Go.
Oh, that's right. Okay, 12,151.
All right, that's not too bad. And the last one, go for it.
1,481,903.
So my claim was at the start, everyone could do this without any instruction, yet no one could explain it, right? So just keep that in the back of your mind. All right, that's all good. It's pretty cruel to give you one like that. All right, I said 3 games. The next game is the reverse of that, the converse, right? Now I'm going to give you the words. You got to write the numbers. So what are the only one that will cause you problem? I'll go back to this. What is the only one that will cause you problem? Which one? The 1 million? No, I mean, it's got a 1, it's got a 4, it's got an 8, it's got a 1, it's got a 9, it's got an 8, it's got a 1. I mean, it's pretty simple. Which one's going to give you a problem? The one that has the zeros. And if it's a really large number and it's got a lot of zeros, you just got to be careful, right? So it's just the reverse of the previous one. Remember, we go from left to right when we're writing it down. The commas in the sentence or the phrase represent the commas in the number. And it could or could not have an and in it. So let's see, 10,000, comma, well, it says 10. That's pretty easy, right? So we go 10, comma, 101. All right, well, there you go, and you're done, right? And the cool thing about it is you read it from left to right. As long as there's not a bunch of zeros, it's easy to figure out. You can literally just write what it says. When there's a bunch of zeros, that's when you need to pause and make sure you put in the correct number of zeros. All right, so 42 billion. Uh-oh, we got a problem. Lots of zeros. 42 billion, right? Well, clearly it starts off with a.
Oh, big number.
Clearly it starts off with a. Clearly it starts off with a. All right, so it starts off with a 42. But it says that's billion, and then all you have is 557. Question is, well, how many zeros is that? Well, what's going to save your butt on this one? There's actually 9 zeros in a billion, right? There's 6 zeros in a million, but there's 9 in a billion. What's going to save your butt is this chart that I keep showing you here on the left that none of you wrote down. Okay? Then you will get it right. The rest of them will get it wrong because they will put the wrong number of zeros. So if we're in billions, how do we get to hundreds? How many zeros are there? Does this say hundreds? Does that 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 say hundreds? All right, so it's got 1, 2, 3, 4, 5, 6 zeros that I've got to add. One, there's 3, there's 6. You see how I did that? And now I can write.
557.
Can someone think of a better way of doing that?
No.
Okay. Do I require you to write that down? No. So most kids will not ever have that written down, but you better think about it. This would be a perfectly good test question. It will separate the people that know what they're doing and the people that don't. Right? I put you one that has no zeros, everyone gets it right. It's impossible to get it wrong almost. But if I put one that has lots of zeros, lots of people get it wrong. They don't put the right number of zeros. So beware, I've already told you what the test question is. All right, you have 3 in front of you, do them. Box 4. All right, well then I'll give you 30 seconds, get them done. Anybody need help? Sarai, you got the first one? Tell me what to write. First one, tell me what to write. Oh, I got you. Go ahead.
73,0.
How do you know it's only 1 0? How do you know it's only 1 0?
Because it doesn't say.
It doesn't say 100, so then we have 1 0 in the hundreds place. All right. Next one. All right, go ahead, Carson.
5,000,000.
5 comma.
5,000,000,000.
All right. How did you know that many zeros?
Because that's millions. There's no thousands, and there's no hundreds. There's no tens.
And there's no 100,000s either.
Okay, there's no 100,000.
Right. So just make sure it's clear in your mind that you know that this is the process. And the last one, who's got it? Right. Somebody new that I haven't called on. Thank you, Jake.
Oh, yes. 6213.
6,
comma 1, 2.
one more try.
6,000.
No, tell me the numbers to write.
6,
Comma.
213.
Tell me the numbers to write. You just read what it says.
I'm so dumb. 6,213.
Perfect. Good job. Because otherwise, I mean, obviously, if you read it, then that's what it says, right? Okay. We good? All right. We said 3 games. The last game is, well, technically, I guess it's the most challenging of the day, but it's not really that bad. It's pretty easy. All right. So here we go. So we're going to write those type of numbers in what's called exponential form. Let me show you what that means. All right. I do need you to write this down.
In this 5?
Yeah, in box 5. And we're going to add something to this. It's just not going to be just these words, because you should have that memorized. Grab your pencils, start writing.
Can we just have it?
No, you got to write the words. You'll see why here in a second. All right. Last night for homework, we did what?
We did the numbers. Same thing as this one.
No,
We did where you have to put the tiny
we did exponents. Thank you. Exponents is a base and a small number to the upper right. It turns out that we can write all of these words with exponents.
Oh, that's good.
So for instance, how can you write 100 as a number with an exponent? What do you got? How do you write 100 as a number to a power? Well, that wouldn't be an exponent, then would it? So how do we write 100? 100 to the first power, there's one way. I'm going to choose not to write 100, I'm going to choose 10. Why 10? Because we have a base 10 number system. So how do you write 100 as 10 to a power? 100. 10 to what power is 100? 10 to the second power is 100. So next to the word 100, I want you to put 10 to the second power, because that's 100. Remember, I'd say both ways, 10 squared or 10 to the second power. How do we write 1,000? 100, no.
10 times 10 with an exponent. 10.
How about 10 to the
10th power.
To the
1,000?
third.
To the third power. How do we write 10,000?
10 to the fourth.
Do you see a pattern emerging?
Yes, I do.
So then what? How would you write 10?
10 to the 5th.
10.
10. 10 to the 1.
Going back to tens.
Oh.
10 to the first, or just plain old. Remember I said we don't have to write to the first power. Just plain old 10. Well, how would you write 1?
You would write 1 by 1.
Follow the pattern.
Negative
4, 3, 2, 1.
0.
10 to the 0 power is the number 1. Oh, sorry. Wrote one. You can. All right. So let me catch up with you. 100,000 would be 10 to the 5th. A million would be,
10 to the
Laura, grab your pencil, write this down. 10 million would be,
7.
100 million would be,
8.
and a billion would be,
9.
and we said 1 would be 10 to the 0 power.
I only confused on the 10 to the 0.
Okay, we'll follow the pattern. What happens?
0, 1, 2.
Here's another way of thinking about it. If I wrote 10,000 and I divided by 10, I would get 1,000. If I take 1,000 divided by 10, I would get, I'm just dividing by one number. 100 divided by 10 is, and 10 divided by 10 is, and there's the pattern. It's got to be 1. 10 to the 0 power has got to be 1. All right. Okay, so why did I make you write all this down? Because here's what we're going to do. We're going to write one of those big numbers as an exponential number. How does that look? Well, let me show you how it looks. All right. So it's going to look like this. So obviously 7,433. Yes?
Yeah.
Eyeballs on the board. Okay. So, well, that's in written form. In exponential form, well, I don't know how to do that, but I could write this as the sum of some numbers. Watch what I do. 7 is in what place? So this would be, you agree that would be 7 times 1,000? Same number
Yeah.
as this?
Nope. Oh, wait, yes.
I mean, isn't that 7,000?
Yeah.
So isn't that the same thing?
Yeah.
Plus
433.
4 times
100.
plus
3 times 30.
plus.
3 times 1.
All right, there we go. Now my claim is that we can write, because mathematicians are lazy or efficient, that we can write this using exponents. We can. Look at the thing you just wrote down. What is 1,000?
10 to the 20 power.
So instead of writing 1,000, I could write that is times 10 to the 3rd. Instead of 100, I could write, instead of 10, well, 10 is 10, and 1 is 1. So I'm going to claim that's an exponential form.
Can we still write the other way?
Nope, this is exponential form. This is writing that number in exponential form. So that's what we're about to do. So you need, if you don't have this memorized, and I don't think any of you do, you need to have that box with those numbers, because that's going to tell you what numbers to write for your powers, or your 10 to the power is more specific. So let's do one together. Here we go. This is box 6. What direction are we going to go? Pay attention, Jake. We're going to go left to right. Jake, what's the first number I see?
6.
What place value is it in? Look at your chart. What's 100,000? 10 to the, look at your chart. Did you write it down?
I got a little bit of it.
You got to write the whole thing down. It's 10 to the 5th power. 10 to the 5th. So we're going to write that as what?
10, 5 times 6.
6.
Plus, 10 to the 5th.
6 times 10 to the 5th. Anybody lost in what I just did there? Hopefully you're not enthused about it, because it's not something to be enthused about. All right, next digit. If it's a 1, we're going to write 1 times 10 to the,
4.
right? So it's in the 10,000 place. We look at the chart. 10,000 is 10 to the 4th. Plus, next digit,
7.
times 10 to the,
3rd.
oh, this is just going down in decreasing order. Yeah, it is. Until we get to a 0. Next number is not a 0, it's a 1. 1 times 10 to the Just like writing the words, guess what we do with zeros? We leave them out. We skip them. Just like writing in word form, we're going to skip them. The last number is 1, 1. Well, it seems ridiculous to write 1 times 1. So you could just simply put plus 1 if you wanted to. But I wrote it out 1 times 1. Get it? Easy or hard? You better have this chart in front of your face, or you got to have it memorized. Jake, what's a billion? You got it now. All right. There are 4 numbers, then we're done. Right? These 4 numbers in exponential form. And yes, they are the same numbers that we wrote with words, because I was efficient or lazy, one of the two.
Whatever one you want to call yourself.
Anybody not know what I want you to do? Does anybody need help? David, we good? Let's do one together, David. All right. What's the first digit? So write 7 times. 7 is in what spot? Over thousands is what? 10 to the plus. Next digit is a 4 times. Right there, 4 times. 4 times. What place is there 4 in? Hundreds is in the second. In the second. Plus 3 times. Times 10. 3 times 10 is 30. 3 times 10. Really, it's 10 at the first. And then plus 3 times 1. Can you do the next one by yourself? We'll do it exactly the same way. Can you do this one by yourself? You can, absolutely. You absolutely can. You can write 3 times 1 if you want to. Hey, what's that say right there?
That says 2 to the 0.
What's 2 to the 0 power?
2 to the 0 power 2.
1.
0 is not.
1.
Okay.
1.
It's 1. Anything to the 0 power is 1, with one exception. 0 to the 0 we say is 9 to 5.
Wait.
Wouldn't make sense that 0 to the 0 power would turn into a 1. That doesn't make any sense. Which one is the hardest one?
1 million.
It's painful.
I'm in.
The nice thing is there's no zeros, so it just follows decreasing order.
That's not.
So once you have the first one done, the rest are really easy to do. The ones that have the 0 are the ones you got to be careful with. Test question, I would probably put the zeros in the middle and then throw some digits around it to force you to have you look at that chart or make that chart. Could you make that chart if you didn't have it on your resource card? Okay. Guess not, what number are you going to start with?
0.
Okay.
Actually, the last one's pretty easy.
It just takes a lot of writing, correct? Yeah. Nothing challenging about it, just takes a lot of writing. All right, you ready to check this?
No, say the last
All right.
one out loud.
Richard, you got the first one, upper left, go.
7 times 10 to the third power, plus 4 times 10 to the second power, plus 3 times 10 plus 3 times 1.
Very good. Lower left, who wants it? Antonio, good job. Tell me what it is.
7 times 10 to the third power
Plus,
3 times 1.
and that's it. All right, who wants this one? Go.
1 times 10 fourth power plus 2 times 10 third power plus 1 times 10 two power plus 5 times 10 plus 1 times.
There you go. And Tony gave me that one. And the last one, what do you got?
Okay. 1 times 10 to the 6th power plus 4.
plus 9 times 10 to the second power plus 8 times 10 to the first power.
We finished just on time. Very good. Excellent job, and I'll see you guys tomorrow. Yep.
Easy.
Yes.
All right, e-learners, that'll do it for today. If you have any questions, send me an email. If not, I will see you guys tomorrow. We will, we don't have no quizzes or tests this week, so just nothing but classes. Catch you guys later.